Hello everyone, we're making a large bedroom unit. In the last video we went through the process of designing and building a raised panel door. In this video we're staying with raised panel doors, but one of the doors needs to have a sloping top and the other door only has 3 sides. Yes, it's a triangle. Can we make a raised panel door properly with only 3 sides, or does it become a bit of a bodge up? I've made a full-size template of the 2 doors we need to build. This is one door on the right of the sheet and this is the second on the left. The ceiling comes up at an angle. I've added a 14mm overlap all the way around, so the inside line here is the size of the hole in the covered unit and the outside shape of the cardboard is the finished shape of the 2 doors with a 3mm gap between them. Now, how am I going to make these door frames? I've been trying to work out the best way to build these doors. The door frame width must be the same as all the other doors. The angle of the frame down here is 32 degrees. Now I have that angle, I can work out the other angles the frame pieces must be cut at. I've decided to go against convention. The rails here and here will go full width across the door and the 2 stiles will fit between them. I think this will make the doors easier to assemble. Well, we will see. There are 2 profiles to route on the frame of the door. On the inside of all the members, the female profile must be machined. This will hold the raised panel in position. The second shape to route is the male profile. It needs to be cut at both ends of the 2 vertical members. The top 2 cuts are going to be interesting as they must be cut at the correct angle to meet the slope of the top member. Now, let's look at the door on the left. Initially I thought, oops, this isn't going to work. It's going to be a bit of a bodge. But then after a bit of head scratching it dawned on me. This piece stays with 90-degree corners and has a female profile machined along this one edge. The other 2 pieces are machined with their female profiles along their edges just here and here. Now, all we need to do is cut the slope piece here, cut the vertical pieces here, then machine male profiles on each of the angled cuts. We are left with this. Where I've cut a female profile, I'll show that in red. That's here, here and here. Where the male profile cuts are made, I'll show that in blue. That's here, here and here. So, as you can see, it works out very nicely. Male profiles in 3 positions around the frame mate with female profiles. And the 3 frame sides that face into the centre are all female profiles, and that will hold the raised panel. No bodges at all. The stile and rail cutter is in the router bench. Using the setup jig, I've set its height to cut the female profile. I cut a test piece and check it against the male jig. I'm happy with it, so machine the 7 pieces of frame that will make up the 2 sloping doors. I move the feather edge to one side and then push back the fence. The router needs to be set to cut the male profile. I lower the cutter and using the male profile setup jig, set the cutter height. Next, I set up the fence and the mitre fence. These must be at 90 degrees to each other. And the rear fence must also be in line with the outer race of the bearing in the cutter. I cut the male profile into a test piece of frame. That test piece is checked against one of the female profiles I just cut. The surfaces here and here didn't line up exactly. I adjust the cutter height and try again. This time the surfaces do line up. I cut that profile on 3 pieces of frame. This is where we are. The female profile has been cut on one side of all the frame members. The male profile has been cut on one end of each of the vertical members. I can form square corners by pushing home the 3 vertical sides into the 2 horizontal base pieces as shown. The next thing I need to do is cut the male profile in the top of the 3 vertical sides. This piece of machining not only has to be at the correct angle, but the sides must be at the correct length as well. I'm fairly confident that the template is the correct size and I've checked that. I've put this on the template right along the edges where it needs to go and also along the edge here. These joints have been pushed together, so I'm fairly confident that this lower end is true to the template. This piece I've lined up with the edge of the template along the top, and this my little protractor here I've set to 32.5 degrees off the vertical, off the horizontal. So I'm pretty confident this is where the door has got to end up. So, this is where the top of the frame has got to end up. So I'm marking along here. That's where it's going to finish up. But you've got to remember that the shape to be machined on here has got to suit this beam, so it's going to sink in by 10 millimeters. So to get the correct position, what I'm going to do is check that this angle is correct, which it is, push it up, but then measure 10 millimeters from the edge of the protractor to the line that I've just put in there. So it mustn't be vertical, because that won't give you enough space. It's got to be perpendicular. It's got to be 90 degrees to this edge in that direction, 10 millimeters. So I will bring it up to there. Put this line in, and that's where this member has to be cut and then machined for this to fit correctly. I decided to go on the cautious side here, and instead of going 10 millimeters up, I've gone 12. The idea being that if these measurements work out slightly under, then this will be spot on. If it turns out to be too high, then I can always cut a little bit off later. At the miter saw, I cut both verticals to the lines that I'd drawn. It's now time to route along this angled face. Now I was thinking about moving the miter gauge such that it was at the correct angle to push it across, but I'm a little bit worried because the router bit goes round in an anti-clockwise direction. So if it did snag up or try to pull the frame in this direction, it's going to hit the miter fence that's at an angle and push it in, and it doesn't seem right to me. So I think this is long enough for me to route along like that, and I'll do the same with the other bit of frame. There is a gap in the centre of the fence where the cutter sits. This means as you slide the frame member up the fence, it will lose the support of the fence as it passes the cutter. You must keep the frame member at the correct angle and against the fence. As the cutter starts to cut, you will lose the support of the fence at the front of the frame. Bias your push against the fence at the trailing edge of the frame. Now, as the frame bridges the gap in the fence, start to bias your push against the fence towards the forward edge of the frame. You'll have to be very careful not to let the leading or the trailing edges of the frame pieces move into the gap. If you do, the cutter will cut too deep and you'll have to start all over again. Here's that right hand door now. These two uprights have been machined. You can see that the machining is taken quite well. It hasn't broken away any of the edges, which is really good. I now fit the other piece of wood that goes across the top, or the top of the frame, onto here. Now I can't really do this with one hand, so I will get back to you in just a moment. And what do you know? It worked. It all goes together quite nicely. The edge along here it's almost together. Once it gets clamped, after it's been glued, that will all close up. What I have to do now is this needs to go up a little, get level at this end, then I cut the edge off of here, across the top, and square it off. I'm feeling quite pleased with that. In fact, it is actually 2 millimeters too tall. So the 2 millimeters I put on here as a safety, I didn't need to. So I'm going to take them off now. So I'll cut 2 millimeters off each of these uprights and then go through on the router again just to machine them back to the correct size. This is now all cut to size and it's looking pretty good. I'm very pleased with this. I'm going to leave these ends long. We've got to cut the top off here to square it off, get 90 degrees in this corner, and then cut along there. But what I'm going to do is glue it together first. So I've got the centre panel to make, glue this together, and then once I'm happy with it, I can then cut the outside to the correct dimensions to suit the template and also the wall. So this one is finished for a bit, and now I'll go on to the other door, the left-hand door, the more difficult one. What do you know? It worked. You can make a triangular raised panel door and have all the machine sides mating properly with each other. The last time we saw this door, it had the female profiles cut down these three sides. Since then, using the cardboard template for dimensions and angles, I cut the male profiles here on top of the verticals and here on the lower end of the sloping top. It worked! Well, what do you know? You can make a raised panel door with just 3 elements in the frame, and the machining for the router, it all ties up. You can see here it comes in quite nicely, and across here, in all the corners are all whole. It's going to be a fairly small panel. I'm not sure if we're going to see a triangle in there. What I may have to do is just use a sheet of 6mm MDF, but we will see that later on. But anyway, both the doors are ready to have their panels. So the next job is to make the panels, fit them in, and then glue everything together. Once it's all glued together, then we can cut the doors to their final size. At the router bench, I disconnect the mains power, then push back the fence and remove the stile and rail cutter. Fit the panel raising cutter in the chuck and adjust its height to the same as it was when I machined the panels for the other doors. That is 6mm from the top of the cutter by the bearing race down to the surface of the table. Set up the fence so its front face is level with the outer race of the bearing on top of the cutter. I turn the cutter by hand to make sure there's clearance between it and the fence. Then once the feather edge is set, we are ready to cut. I reconnect the mains, power up the motor and start to cut. The small triangle is first and then the panel for the larger door. Made the panels just the same as I made the panels for the other doors, except this one is at a funny angle to suit the door. The one on this side we had some trouble with. If you notice, it's been eaten away on this edge. And the problem there was when this is being put through the router, it's up this way and you push it across. The cutter is so large, there's a large hole in the bottom of the table of the router and and this land falls into it, and as it falls into it, the cutter chews out that hole. So what I've decided to do just here is have a piece of just standard wool. So this is MDF 5mm, and that will go into the side there. So the next job is to take these two things apart and stick back together. The workbench is nice and flat, an ideal place to glue the two doors. I don't want the doors to stick to the bench, so I place a layer of cling film on its surface. I pull the small triangular door apart, apply the adhesive to the mating surfaces and clamp it to the bench. More cling film and onto the larger door. It's soon clamped down. This clamp, this dog and the two tapered packing pieces hold the sloping top piece in position. These two clamps provide the squish that's needed to hold everything together. This dog is there to stop the sides moving while under pressure from the clamps. That side could slide up the angle of the top piece. The larger door is clamped in a similar fashion. I'd forgotten to place a dog or a clamp here to stop any movement of the side piece. I was lucky, nothing moved overnight. For those of you who haven't seen the orange ducks before, they're eccentric clamps. Now I don't mean they make mad inventions or bathe in goose fat, but the hole you see the metal dog passing through is off centre. As you twist these devices using the heads of the duck, it exerts a force here and here, clamping the doors together. These two doors are now nicely glued together. They are slightly oversized on some of the corners, and I left it like that on purpose, so now I can cut them back to the correct size and they should fit into their place quite nicely. So that's the next thing. Get the track saw out and cut these off so they are the correct shape. I make sure the marking out on both doors is correct. I get the track saw ready and perform the final cuts to the two doors. And there they are, finished. The two sloping doors complete. Building the doors for the wardrobes is similar to building the cupboard doors. In this image you see the first 2 cupboard doors. There's 6 of them now, all waiting to be installed. There are also 6 of these, the double panel doors for the 3 small wardrobes. And not forgetting 2 of these, also double panel doors, but the largest I've ever made. They are of course for the single large wardrobe. The assembly of the wardrobe doors is similar to that of the cupboard doors. There are of course more pieces, so you have to think about how you're going to clamp it before you go mad with the wood glue. And that is it. All our raised panel doors are finished and ready to be hung. In the next video we're going to be looking at hinges. What type of hinges we need to hang our doors and how we have to machine the doors to accept the hinges. There's more to a hinge than meets the eye. Can you do something like this? Of course you can. And with that, this video is at an end. Take care everybody. I'll see you next time. Could you do something like this? Of course you can.